Hello, welcome back to Cinderella Math. Today I'll be doing solving exponential equations that involve fractions. These will not require logarithms. Uh, there is a possibility that you could do it that way, but I won't be doing it that way. It'll be changing the bases to match. I do have another video in my Algebra 2 playlist doing this same topic. I did one or two with fractions, but this video will be solely with the fractions. So if you need more basic ones without fractions, just look on the Algebra 2 playlist and you will find that there. Okay. All right, let's just jump right in. So I'll do maybe like 5 examples here. There is a trick to this. Let's call this example 1. And I have 64 to the power x minus 3 equals 1/4 to the power negative 3x. So we cannot solve that yet because this base, the guy with the exponent, does not match this base. If they matched, we'd be in business. So when you think about something to some power is 64, what comes to your mind? Probably 8 squared, and sometimes that's what we do want. But I don't think I can get the 1/4 to be an 8. So that's a good guess. If that came to your mind, it's fine. What else comes to our mind with 64? And we can even do a little factor tree if you need to. 64 is 8 times 8, and then 8 is 4 times 2, 4 times 2, and then these 2's can get together. 2 times 2 can be 4. So 1, 2, 3, 4s. So 4 cubed is 64. Now we're in business because we can get 1/4 into a base of 4. The trick is just look at the denominator. 4 to what power is 4? Well, to the first, right? Anything to the first is itself. And then the trick with fractions is negate. Why is that? Well, 4 to the negative 1, you've learned before when you've been doing properties of exponents that we're not technically supposed to have a negative exponent. So we make it into a fraction, we send him to the bottom, and we put a 1 on top. And there it is. So the trick is when you're dealing with these with fractions, just look at the denominator, figure it out that way, and negate. Now we can make our substitutions. Coming back to the problem, this is kind of what I like to call side work. 4 cubed is 64. So let's replace 64 with 4 cubed. And he still has the power of x minus 3. And then 1/4 is 4 to the negative 1. From our side work, he still has the power negative 3x. And now the bases are the same, so these exponents must be the same. And we just set the exponents. So basically these are gone. I call that the capuche method if you've watched my other video on this. Capuche. And we have 3x minus 3 equals negative 1, negative 3x. And let's solve. 3x minus 9 equals 3x. Oh, are we going to get a no solution here? I did not mean for that to happen. This is gone, and that's 0. 0 does not equal negative 9. Did we just do all that work for no solution? Give me 1 second. I didn't mean for that to happen. Yeah, that's correct. All right, sorry. The work was still all right, and that does sometimes happen. It is sometimes just not possible. Let's do one that is possible here. I'm going to make sure this has an answer. Yes, we're good. All right, example 2. All right, we have 25 to the negative 3n minus 3 equals 1/625, no power. So again, this is not possible at this moment because the bases are not the same. So let's do our side work. What do you think of when you think of 25 in terms of powers? You think 5 squared, and you'd be totally right. 5 squared is 25. And now coming to our fraction, just look at the denominator. 5 to some power is hopefully going to come out to 625. I don't expect my students to know that off the top of your head. I do because I've been teaching math forever, but you can use your calculator and just guess, or you could do the tree again, whatever works for you. It is to the fourth. But then since this was a fraction, negate. There we go. Now we can solve this problem. Let's make our substitutions back to the problem. 25 is 5 squared. The power is still there. And 1 over 625 we did on our side work is 5 to the negative 4. Now we're cooking. The bases match and you can get rid of them because this power now needs to match this power. Bye-bye, bye-bye, or kapoosh if you watched my previous video or if I've been your legit teacher. And let's distribute. Negative 6n minus 6 equals negative 4. Solve. I'm going to add 6. Negative 6n is 2. Divide negative 6. Reduce 6 to negative 1/3. I always put the negative on top. If you have it to the side or to the bottom, it's fine. It's just my habit to put it on top. As long as it's there, you're good. Right, I'm going to do maybe 2 more examples here just to get you in the hang of this. I have 1 over 216 to the power negative 2x minus 3 equals 36 to the 3x. And let's do our side work. I start with whatever looks easier. The 36 looks easier. What comes to your mind exponent-wise with 36? Probably 6 squared. Yeah, that's good. So now, looking at this one, take the denominator, and we want it 6 to some power is 216. Again, you can guess around on the calculator, or you can do a number tree if you're not allowed to use a calculator. It should be 6 cubed, 6 to the third, yes. But then it was a fraction and negate. That's all there is to it. We can solve. Let's replace that fraction with 6 to the negative 3. Keep the power. Let's replace 36 with 6 squared. Keep the power. The bases match, so those are basically done, and solve the rest. Distributing. 6x plus 9. Distribute. 6x. Is this another no solution? I did not mean for that to happen. It is. That's okay. That happens. Got a minus 6x, which is 0, minus 6x, which is 9. Those don't equal. No solution. But you know, even if you get no solution, you still have to show your work, right, for credit. So it was still good work. Okay. See here. Example 4. Okay. Find a good one that hopefully has an answer. I have 1/27 times 9 to the 2 minus 3n equals 9. Side work. Go to the easiest thing, which is probably going to be this 9 or this 9. Doesn't matter. They're both 9s. And what do you think of when you think of 9 in terms of exponents? You think 3 squared. So if we could get this one to be a base 3, we'd be cooking. So again, just look at the denominator. 3 to some power is hopefully 27. And it's 3 cubed. And negate because it was a fraction. Now we can do this. Let's replace 1/27 is 3 to the negative 3 times 9 is 3 squared. Keep the power. equals 9 is 3 squared. Now this is one step up from our previous problems because we cannot solve this yet. This left-hand side needs to be condensed into one piece. Remember your exponent rules. When you see multiply and you have the same base, which we do now, we changed it so it's base 3, you really add the exponents. Example to the side here. If it's x4 times x10, you add, and it's x14, right? So here we're going to keep the 3 and we're going to add the exponent. So we're doing -3 add 2 times 2 minus 3n. And this other side was fine. Now we can get rid of the 3's. Now that we've condensed it into one singular exponent here and one singular here, 3 to this blah, blah, blah equals 3 to this. Bye-bye, bye-bye. And I'm going to come up here for room. We have -3 plus 2 times 2 minus 3n equals 2. And solve as normal. So this was one step up. Distribute. Combine like terms. So we have -6n equals 1. Divide -6. And n is -6. That does not reduce. Just leave it. So that was definitely one step up. I'm checking that one to make sure, just on the off chance that that was not. No solution. Yeah, it's good. Okay. All right, I'm gonna just do I'm gonna make up one in my head and then I'm gonna call it a day here on this video. I don't like any more on this piece of paper I'm using for a reference. Last one, example 5. Let's do 1 over 32 to the x plus 4 times 16 to the x equals 1 over 8 to the x minus 5. Again, I just completely made up in my head. It may not turn out pretty, but that's okay. Let's come to our side work. Probably the easiest thing is the 16, and you think with 16 you'd go 4 squared, and sometimes you would. But I don't think I can turn 8 to a 4 or the 32 with exponents. So if you also think about 16, and you break that down, 4 times 4, 2, 2, 2, 2, 1, 2, 3, 4. So 16, we could also say, is 2 to the 4th. And that's the one I think we're going to use. Because looking at this denominator, 32, 2 to some power is 32. Now you could either do your tree or you could just guess around in the calculator. It's 5 and then negate because it was a fraction. And then same thing over here. Just look at the denominator. 2 to some power should be 8. That's 2 cubed. And then negate because it was a fraction. So we can turn all of these to base 2. Let's make our substitutions. So 1/32 was 2 to the -5th, keep the power, times 16 was 2 to the 4th, keep the power, equals 1/8 was 2 to the -3, keep the power. All right, again, this left-hand side is not ready. When we see a multiply, we really add the exponent. So we're going to keep that base 2, and we're going to do -5 times blah, 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 plus, you can just say that's 4x, equals this guy. Now we're good. So remember that trick. Whenever you have multiply, you're really going to add the exponents. That's an important trick to remember. Important rule. Now, bye-bye, bye-bye. I'm going to come up here to solve. Distributing. That's -5x minus 20 plus 4x equals, distribute, negative 3x plus 15. Combining like terms, negative 5 plus 4, so that's just negative 1x, or just negative x, minus 20 equals negative 3x plus 15. Solving, I'm going to add 3x, which is 2x. I'm going to add 20, which is 35. Divide 2, that does not reduce. I would just leave it like that. You could go decimal, but I would just leave it. 35 halves. Woo! All right, I hope this was helpful on how to solve exponential equations using fractions and how to convert fractions to a better base. It is not always possible, and that's where logarithms come into play, but I did not go there in this video. All of these were possible to convert. Let me know if you have any questions, and I hope you're having a great day. Bye-bye.